You've dreamed of traveling to the stars, exploring distant worlds, and meeting alien civilizations. Science fiction has promised you faster-than-light travel, warp drives, and galactic empires spanning thousands of light years. But Stephen Hawking spent decades proving that these dreams are not just difficult to achieve, they're physically impossible. The laws of physics themselves conspire to trap every civilization, including humanity, in their home solar systems forever. This isn't about technological limitations or engineering challenges that we might someday overcome. This is about fundamental barriers built into the fabric of reality itself, mathematical impossibilities that no amount of scientific advancement can ever solve. Hawking discovered that the universe is designed like a cosmic prison, with invisible walls that become stronger the harder you try to break through them. What if I told you that every sci-fi movie you've ever watched is based on a lie? That faster-than-light travel isn't just beyond our current technology, but violates the basic structure of space and time. Hawking's analysis reveals why we will never explore the galaxy, why we will never meet aliens from distant stars, and why humanity is doomed to remain forever isolated in our tiny corner of the cosmos. This isn't pessimism, this is physics. And once you understand the iron laws that govern interstellar travel, you'll realize that our cosmic isolation isn't a temporary problem waiting for a solution. It's a permanent feature of reality itself. Before we dive into the mathematical prison that traps all civilizations in the universe, hit that subscribe button because we're about to explore the most sobering truth in all of physics. Stephen Hawking's journey into the impossibility of interstellar travel began with Einstein's special theory of relativity and a simple but devastating equation, E and mc2. This innocent-looking formula contains within it the death sentence for all dreams of galactic exploration. The physicist realized that as you approach the speed of light, your mass increases toward infinity, requiring infinite energy to accelerate further. But the problem goes much deeper than just energy requirements. Hawking understood that space and time are fundamentally linked, and traveling at high speeds doesn't just require more energy, it literally changes the nature of time itself. As you approach light speed, time dilation becomes so extreme that the universe ages around you at an incredible rate. A journey to a nearby star might take only a few years from your perspective, but centuries or millennia would pass on Earth. This creates what Hawking called the temporal isolation paradox. Even if you could somehow reach another star, you would return to find that everyone you knew was dead, your civilization had evolved beyond recognition, or humanity itself had gone extinct. You wouldn't be exploring the galaxy, you'd be traveling through time, watching civilizations rise and fall like flowers blooming and dying in fast forward. The physicist calculated that this time dilation effect makes round-trip interstellar travel essentially equivalent to one-way time travel into the future. You can leave your home world, but you can never truly return to it, because the world you left will no longer exist by the time you get back. This isn't a side effect of interstellar travel. It's an unavoidable consequence of the structure of space-time itself. But even if you could somehow accept this temporal exile, Hawking's analysis revealed even more fundamental barriers. The energy requirements for accelerating a spacecraft to relativistic speeds are not just large, they're physically impossible to achieve. To accelerate even a small probe to 10% of light speed would require more energy than our entire civilization produces in a year. And here's where the physics becomes truly cruel. The faster you want to go, the more massive your fuel becomes due to relativistic effects, which means you need even more energy to accelerate that fuel. This creates an exponential feedback loop that Hawking called the tyranny of the rocket equation. No matter how efficient your propulsion system, you eventually hit a mathematical wall where the energy required becomes infinite. Think about what this means. It's not that we need better rockets or more efficient engines. It's that the fundamental structure of reality makes high-speed space travel impossible for any technology based on known physics. The universe itself is designed to prevent interstellar travel, as if cosmic speed limits were built into the very fabric of existence. Hawking also explored more exotic propulsion concepts like antimatter engines, fusion ramjets, and even theoretical concepts like the Alcubierre warp drive. But his analysis revealed why each of these approaches faces insurmountable barriers rooted in fundamental physics. Antimatter is incredibly difficult to produce and store, requiring more energy to create than it releases when annihilated. Fusion ramjets, which would scoop up interstellar hydrogen for fuel, face the problem that interstellar space is nearly empty. The drag created by collecting fuel would actually slow the spacecraft down more than the fuel would speed it up. It's like trying to power a car by having it scoop up gasoline from puddles on the road while driving. The process of collection creates more resistance than the fuel provides thrust. The Alcubierre warp drive, which theoretically allows faster-than-light travel by warping space-time itself, requires exotic matter with negative energy density. Hawking's calculations showed that such matter cannot exist in the quantities needed, and even if it could, the energy requirements would exceed the mass energy of the observable universe. The warp drive isn't just impractical, it's mathematically impossible. But perhaps most devastating was Hawking's realization about the nature of information and causality in faster-than-light travel. Einstein's relativity shows that faster-than-light travel is equivalent to time travel into the past, which creates paradoxes that violate the fundamental principle of causality. The universe seems designed to prevent these paradoxes by making faster-than-light travel impossible. This isn't just a technical limitation, it's a fundamental feature of reality. The speed of light isn't just the speed at which light travels, it's the speed at which causality propagates through the universe. Exceeding this speed would allow effects to precede their causes, breaking the logical structure of reality itself. The universe protects its own consistency by making interstellar travel impossible. Hawking's analysis also revealed why even robotic exploration faces nearly insurmountable barriers. Sending unmanned probes to nearby stars would take thousands of years, and the technology would become obsolete long before the probes reach their destinations. By the time a probe launched today reached Alpha Centauri, humanity would have developed technologies that make the probe's instruments look like stone tools. More importantly, the communication delays make controlling distant probes impossible. Radio signals take years to travel between stars, making real-time control impossible. A probe at Alpha Centauri would be on its own for decades or centuries, with no possibility of receiving updated instructions or sending back data in any reasonable time frame. Let me ask you something that might shatter your dreams of space exploration. If the physics of our universe makes interstellar travel impossible, what does that say about humanity's ultimate destiny? Are we doomed to remain forever trapped in our solar system, watching distant stars but never reaching them? Share your thoughts in the comments below, because this might be the most important limitation our species will ever face. The physicist also considered the possibility of generation ships, massive vessels that would take centuries or millennia to reach nearby stars, with multiple generations of humans living and dying during the journey. But his analysis revealed why even this approach faces impossible barriers. The engineering challenges of building a self-sustaining ecosystem that could function for thousands of years are beyond anything we can imagine. More fundamentally, the psychological and social challenges of generation ships might be insurmountable. How do you maintain a civilization's motivation and purpose across hundreds of generations? How do you prevent the ship's society from evolving in directions that make the original mission irrelevant? The descendants of the original crew might have no interest in reaching the destination their ancestors chose. Hawking calculated that the radiation exposure during interstellar travel would be lethal to biological organisms. The interstellar medium, while nearly empty, contains enough high-energy particles to deliver fatal radiation doses over the timescales required for interstellar travel. Even with the best shielding we can imagine, the cumulative radiation exposure would cause cancer, genetic damage, and death long before reaching another star. The cosmic ray environment in interstellar space is fundamentally different from anything we experience in our solar system, where the sun's magnetic field provides some protection. In the void between stars, spacecraft would be bombarded by particles accelerated to incredible energies by supernovas, black holes, and other cosmic phenomena. No amount of shielding could protect against this radiation over journeys lasting thousands of years. But perhaps most sobering was Hawking's analysis of what he called the maintenance paradox of interstellar travel. Any spacecraft complex enough to support human life for centuries would require constant maintenance and repair. But the spare parts, tools, and expertise needed for this maintenance would themselves require maintenance. You end up needing to bring an entire industrial civilization with you, which makes the spacecraft impossibly large and complex. This creates a recursive problem where the systems needed to maintain your life support systems need their own maintenance systems, which need their own maintenance systems, and so on. The spacecraft becomes so complex that it's essentially impossible to build or operate. You can't bring everything you need because you'd need another spacecraft to carry all the equipment needed to maintain the first spacecraft. Hawking also explored the possibility of suspended animation or cryogenic freezing to reduce the biological challenges of long-duration spaceflight. But his analysis of the physics involved revealed why this approach also faces fundamental barriers. Freezing biological tissue causes ice crystal formation that destroys cellular structures. No known technology can prevent this damage while maintaining the possibility of revival. Even if suspended animation were possible, the spacecraft would still need to function autonomously for thousands of years while carrying its frozen passengers. The probability of critical system failures over such timescales approaches certainty. The passengers might survive the freezing process only to die when their life support systems fail during the journey. The physicists' work also revealed why terraforming distant worlds would be impossible even if we could reach them. The energy requirements for transforming an entire planet's atmosphere and climate exceed anything a small colony could provide. You'd need to bring an entire industrial civilization with you, which brings us back to the impossible complexity and mass requirements that make interstellar travel unfeasible in the first place. More fundamentally, we have no idea how to terraform a planet. Despite decades of research, we still don't understand Earth's climate system well enough to predict or control it reliably. The idea that we could engineer the climate of an alien world is pure fantasy based on our current level of understanding. Hawking also considered the possibility of uploading human consciousness to digital form and sending that information to distant stars. But even this approach faces the fundamental barrier of the speed of light. Information cannot travel faster than light, so digital consciousness would still take years or decades to reach nearby stars, and the transmission would be vulnerable to interference and corruption over such vast distances. The energy requirements for transmitting complex information across interstellar distances are enormous. The signal would need to be incredibly powerful to remain detectable after traveling light years through space. The cosmic background radiation and interference from various sources would make reliable transmission of complex data like human consciousness essentially impossible. Recent discoveries in physics have only reinforced Hawking's conclusions about the impossibility of interstellar travel. The discovery of dark energy and the accelerating expansion of the universe means that distant galaxies are moving away from us faster than light. Even if we could travel at light speed, we could never reach galaxies beyond our local group because space itself is expanding faster than we could cross it. Studies of the interstellar medium have revealed that space between stars is filled with dust, gas, and debris that would be devastating to high-speed spacecraft. At relativistic speeds, even tiny particles become deadly projectiles that could destroy any spacecraft. The faster you travel, the more dangerous these particles become, creating another fundamental barrier to high-speed interstellar travel. The physicists' analysis also showed why even the most optimistic projections for future technology cannot overcome these barriers. Nuclear fusion, antimatter propulsion, and exotic matter all face fundamental physical limitations that prevent them from enabling practical interstellar travel. These aren't engineering problems waiting for solutions. They're mathematical impossibilities built into the structure of reality. Hawking's work on quantum mechanics also revealed why quantum tunneling and other quantum effects cannot provide shortcuts to interstellar travel. While quantum mechanics allows particles to tunnel through barriers, the probability of tunneling decreases exponentially with distance. The probability of a macroscopic object like a spacecraft tunneling across interstellar distances is effectively zero. The physicist understood that this cosmic isolation might actually be necessary for the development of intelligence and civilization. If interstellar travel were easy, civilizations might never develop the deep understanding of their local environment that leads to advanced science and technology. The barriers to interstellar travel force civilizations to focus on understanding and improving their home worlds. This isolation also prevents the spread of destructive technologies or hostile civilizations across the galaxy. If one species develops weapons of mass destruction or becomes aggressively expansionist, they remain confined to their own solar system. The universe's barriers to interstellar travel serve as a cosmic quarantine system that prevents any one civilization from dominating the galaxy. Stephen Hawking never lived to see humanity accept the reality of our cosmic isolation, but his analysis provides a clear and uncompromising picture of our future. We will never travel to the stars, never meet alien civilizations face to face, and never establish a galactic empire. We are prisoners of physics, trapped forever in our solar system by the fundamental laws of the universe. But the physicist also recognized that this limitation doesn't diminish the importance of human civilization. If we cannot spread across the galaxy, then our development of consciousness, art, science, and culture becomes even more precious. We are one unique experiment in intelligence among countless others scattered throughout the cosmos, each developing in isolation. Our task is not to escape our cosmic prison, but to make the most of it. We can explore our solar system, develop incredible technologies, create virtual worlds of unlimited scope, and perhaps even transcend our biological limitations. The universe may have trapped us in one star system, but it has given us an entire solar system to explore and develop. So the next time you look up at the stars and dream of traveling among them, remember that you're seeing distant suns that will forever remain beyond our reach. They're not destinations for future human explorers, but distant lighthouses marking the positions of other isolated civilizations, each as trapped and alone as we are. The galaxy is full of intelligence, but it's all locked away in separate cosmic prisons, each species developing its own unique understanding of existence in perfect isolation. If this exploration of Stephen Hawking's devastating analysis of interstellar travel has shattered your sci-fi dreams but opened your eyes to the true nature of our cosmic situation, make sure to smash that like button to support more hard truths about the physical realities that govern our universe. Subscribe to our channel and hit that notification bell so you never miss our latest investigations into the fundamental limitations that define human existence. Share this video with anyone who's ever dreamed of traveling to the stars, because understanding these limitations is crucial for planning humanity's real future. And let me know in the comments. If we're truly trapped in our solar system forever, how should humanity focus its efforts and ambitions? Does this cosmic isolation make our civilization more precious or more tragic? What should we do with the knowledge that we'll never explore the galaxy? Drop your thoughts below and join our community of cosmic realists as we continue to explore the true boundaries of human possibility. The universe may have imprisoned us, but understanding our prison is the first step toward making the most of our cosmic situation.